So hey guys, welcome back to another video. Today we will continue with types of caching. So let me first write the topic which is types of caching. So here comes types of caching. So the first type of caching is client caching, right? Client caching. So what is client caching? The caching that happens on the client side. So client side caching refers to the practice of storing frequently accessed data on the client's device rather than the server. So this is our client, which is the user. So we save all cache on his own device, which is his phone or something or PC that he uses, instead of saving it on the server. So that's how client-side caching happens. This type of caching can help improve the performance of an application by reducing the number of times the client needs to request data from the server. So we don't need to hit the HTTP request again and again, which means that the user can get the data directly on his local device. We can save the cache data, the data that he frequently accesses on his own device rather than on the server, because HTTP requests are expensive, to be honest. Besides that, one common example of client-side caching is web browsers caching, right? When we use our web browser, let's say this is Chrome. So when we use our Chrome, if you see, let me show you some, let's suppose this session buddy, right? If I try to inspect it, now if I go to memory, not memory, wait, it was application. Now if I go to storage, you can, not in storage actually, it's just a second, okay, IndexedDB, cookies, here I cannot see actually. Let me open some of the website, let me open flipkart.com. Okay, now if I go to inspect, wait a second. Now if I go to inspect tool, inside inspect tool, if I go to memory or application, let's suppose, then if I go to local storage, Flipkart, right? So this is the cache, that key value pairs that it has stored, right? So this is how we can store it on the local browser. Okay, so that's one thing, that we can store it on our local browser. When a user visits a web page, the browser stores a copy of the page and its resources such as images, style sheet and scripts. So what happens whenever we load this website? Let's suppose I am loading flipkart.com, right? Now what happens, it try to store all the important data that it frequently need to ask to server. So what it does, it saves all the data on the local device and try to reload it from the same device instead of sending request to the server and getting the response, right? So that happens because this thing never changes, right? This washing machine won't change, the price is stable, right? And there is some caching strategy as well. If it changes, then it pulls the data from the server, that we will learn about later. And this can also reduce the load time, right? So load time will be reduced. So load time is reduced. HTTP requests are less. Okay, so that's how client caching works. Now another example of client-side caching is application level caching. Some applications such as mobile apps can cache data on the client's device to improve performance and reduce the amount of data that needs to be transferred over the network. So same goes, this was the browser example, this was the browser. Now same can happen with the apps as well, right? The apps we use on our device, that can happen with it as well, right? So apps can also use same strategy. Client-side caching has some advantage like reducing server load, faster page load times and reducing network traffic, right? As we are not sending any request to the server, so network traffic will of course reduce, it will reduce, right? And the response time will increase because we are saving everything on local device, right? So however, it also has some drawbacks like the potential for stale data. Stale data means the corrupt data, the data which has not been updated yet, which has been updated on the server, but on your local cache you will still see the old data. So that is one drawback, but you can resolve it using some strategy. So that is one thing. If it is not properly managed and consuming memory or disk space on the client's device. So of course the memory will get consumed if we are storing some cache on the local device, like images or anything, images, videos or content, then it will take some space, right? Now that was about client caching. Now let's learn about CDN caching. What is CDN caching, right? Let me first write the topic, which is CDN caching. So what is CDN caching? CDN means content delivery network, right? This is the network which is built for faster content delivery. That's why it's CDN. Now, a content delivery network is what? It's a distributed network of servers that are strategically placed in various locations around the world. So it is placed, these are the servers that are placed on strategic locations where population is much more greater, like Mumbai, Delhi, or let's suppose Mumbai, Delhi, and what populated cities are Jaipur or Udaipur, cities which has more population or urban areas, right? The main purpose of CDN is to serve content to end user with high availability and high performance by caching frequently accessed content on servers that are closer to the end users. So let's suppose from Mumbai, whole Maharashtra area can be served, right? So Maharashtra can be served from Jaipur, whole Rajasthan can be served, right? So these servers are placed in such a location where large or majority of the population can be covered. Okay. So what happens when we use CDN like Cloudflare, and Amazon also has its own CDN. Let me show you Amazon CDN services. Okay, CDN cloud services. So that is there, and Netflix also has its own CDN. Let me show you. The name is OpenConnect. Yeah, OpenConnect is also one of the good servers, but that is their private server. I don't think they provide these services. OpenConnect. Okay, do they? Welcome to OpenConnect. Okay, they do actually. So yeah, so we can use CDN to load content faster instead of storing on user device, which will take a lot of space. We can use CDN for faster response time and high availability of our services, right? So when a user, let's suppose this is a user, when a user requests content from a website that is using a CDN, let's suppose this is from gets to ISP, internet service provider, some IP is passed to internet service provider, some address, he uses the address to load the website, ISP finds in the data this address maps with what IP address, then it tries to load it, right? Now when loading this IP, what happens? It first checks the content is available in the cache of nearby server. So there will be multiple CDN servers, right? So it will try to check the most nearest server and try to check if content is available or not. If not, then it will try to pull it from the actual server, and it will take some time, right? Because loading takes some time, and it will make sure that this content, after getting fetched from the main server, let's suppose this is the main server, and after getting fetched from the main server, it keeps a copy on the CDN. Okay, and this copy on, if next time if a user makes the same request, then it will make sure it will be a faster response, right? So that is the thing. If it requests CDN caching can significantly improve performance and availability of a website by reducing the distance that data needs to travel, reducing the load on the origin server, and allowing for faster delivery of content to end user. Of course, because we are using CDN, we don't need to make the request to the main server, which means it will be faster, it will reduce the time, it will reduce time, response time will be reduced, availability would be high, and yeah, that's all. Now let's learn about web server caching. So what is web server caching? Web server caching, we have learned about reverse proxies, right? And caches such as Varnish can serve static and dynamic content directly. Web servers can also cache requests, returning response without having. So I have worked on a project previously. So what we did there now, we had our own server on Node.js, right? So there was a Node.js. So what we did, we need this Node server to query our database for any request that comes in. So what we did, we kept one more, we created Redis DB, which is key value pairs, and we use this to let's suppose there are some requests which need some calculation, right, and which won't change. For we created an expiry for them for 1 or 2 days. Like suppose it's a report data, right? So we won't be calculating report every day. We'll be calculating it only once a week. Okay. So what we did, first time the request comes, we try to calculate it, and we try to store it in the Redis in an object or that data format, whatever data format it was available in. Now what happened? On per week, even if user requested multiple times, on the first time it will take around I think it was around 500 milliseconds. Okay, but the second time, if user request again, it will take around 2 millisecond or 10 millisecond or 20 milliseconds max. And this was not a millisecond, it was actually minute. Okay, and on the second I will take around 10, 20 to 300 millisecond depending on the location or the network bandwidth, right? So that was one thing how you can use web server caching. Reverse proxies are basically reverse proxies. If you say reverse proxies, what are these? These are for hiding the IP address from the user, so that our server IP address is not exposed directly to the user. So here also we can, of course, on web server we can cache the data. Okay, so that's how it works. Now let's learn about database caching. What is database caching? So guys, if you are unable to understand anything or I am going anywhere wrong, please write down in the comments. Okay. Now comes database caching. So what is a database caching? Database, it our server communicates with the DB, or we write some query to we write some query to manipulate to get some data from the DB. Depending on that query, we make joins and other things. Okay, so your database usually includes some level of caching in a default configuration, right? Some level of caching is already there and it's optimized for a generic use case. Now tweaking these settings for a specific usage patterns can further boost performance, right? Tweaking the settings much more ahead can also further boost our performance. It's like having a quick access memory for frequently used data in application. Here is a simplified example. So what we can do, we can create a cache of image won't be changing more frequently, right? So first is what? Quick access. So how do we quick access? Quick access. What is quick access? Imagine you are looking up information in a big library, the database. Instead of going to the library every time you need some book, you keep a copy of it on our desk, which is a cache, right? On database cache, we create a caching layer, and instead of going again to the DB, we just store that in the cache. If let's suppose the table is too huge, let's suppose it has around 10 million entries, but the frequently accessed data, the images which are getting frequently accessed, those are only 2 million. So what we can do, we can create a table in cache and we can store it there. So it do not need to traverse all the 10 million copies to search that image, right? So that is one thing which is a quick access. Second is what? Faster retrieval, of course. Faster retrieval. So how is faster retrieval works? Of course, we are storing in cache, so it will be retrieved faster because there are less number of entries. So that is one thing. Now let's saving time, of course, that is also a benefit of it. It saves time. Those are actually same. Now comes different types. Different types. So what are different types? There are different types, different ways to do this caching. You can cache the result of searches. Let's suppose we have searched anything we have created a query. That query is a search query. Okay. So we search anything in the DB, and let's suppose this is first time that search happens, but the results are same, right? Results are not changing. So what we can do, we can save the whole piece of information or entire web page, or we can take a snapshot of web page and save it in the cache, right? We can save it in a cache. Also, there is one more way actually. What we can do now, we can create a count that how many times this search has happened. If it's more than one time, then we can save it in the cache. Otherwise, there is no need to do that. Now, what are benefits? These were all benefits only, but yeah, the benefits. What are benefits? By keeping frequently used data close by, you save time and reduce strain on your library, which is the database, right? It's like having your most used books right at your fingertips. That's a great example actually. When we go to school, right, the most used books, which are like science and maths, right? So we keep them in front of us. So that is how it works. The most used book should be at your fingertips, so making your work faster and more efficient. Okay. However, it's also very important to keep your cache up to date. The data shouldn't be corrupt, or it shouldn't be it shouldn't not be latest. Okay. Otherwise, you might end up with outdated information, like using an old edition of a book instead of the latest one. So managing this cache properly is the key to keeping things running smoothly. Okay, so you have to create some caching strategy and all. Okay, so that was about database caching. Now let's learn about application caching. caching, application caching. Now what is application caching? The application level caching. So like in-memory caches such as memcache and Redis are key value stores, as we know, right? Like between your application and your data storage, since the data is held in RAM, it is much faster than typical database where data is stored on disk, right? So instead of storing it on web servers or using CDN, what we can do, we can store it in memory, which is RAM, right? Because RAM is much faster, it is quickly accessible on your PC, and RAM is more limited than disk. So cache invalidation algorithms such as least recently used, right? So LRU, you can use LRU, the least recently used, you can delete it. Okay, you can invalidate it, the least recently used. Now Redis has the following additional features: persistence option and built-in generally. You should try to avoid file-based caching as it makes cloning auto-scaling. Okay, that's it. So in application level caching, you can use RAM to save your cache and use LRU or least recently used, or there is one more policy, LRU versus least frequently used. Okay, so least recently used and least frequently used. So that was about application caching. These were the types of caching. The first one we saw is client caching, right? The first one we saw is client caching, this one. The second one we saw is CDN caching. Okay. The third one we saw is web server caching. Fourth one is database caching. Fifth one is application caching. So that's about types of caching. Now after that, what is asynchronism, right? Asynchronic operations. So let's learn about asynchronism. What is happening this, guys? Wait a second. Use eraser. Not sure what is happening. What is asynchronism? Now asynchronism workflows has helped reduce request time for expensive operations that would otherwise be performed inline, right? Asynchronism, we are creating the start point of every operation is same, which means it starts at same time. It depends, it's a multiple thread operation, right? It runs on different or same thread, but it starts at same time. So that is a async operation, right? We use await async, right, to start the operation in parallel instead of waiting one to complete then next one to start. Okay, that is not the case. It starts at same time. If you have multiple async requests, it starts at same time, right? So that is what asynchronism is. And they can also help by doing time consuming work in advance, such as periodic aggregation or data. Let's learn about that. Is about asynchronism. You can learn more about it, like sync versus async. Sync is basically this thing is sync and async is this. Okay, you can go more deeper. Now let's that was asynchronism. Now let's learn about backpressure. What is backpressure? Okay, what is backpressure? This is a very interesting topic and you can use it in Node.js actually. If you are a backend developer, you can use this thing. Now what is backpressure? If your queue starts to grow significantly, the queue size can become larger than memory, right? If your queue, let's suppose your queue, you have a message queue and it starts growing quickly, right? It starts growing quickly, the data comes in at large amount, right? So what will happen? The queue size will become larger than the memory, resulting in cache misses, right? If it gets filled, it's get overloaded, right? See, there are many requests, there are many requests, okay? It gets overloaded. So what happens, resulting in cache miss? What happens because this is overloaded? So the items that are out, who will serve that, right? So request will keep on holding, it will keep on loading because these are not yet resolved, which will result in cache miss, right? So discretes and even slower performance. So performance will be slower. So what is backpressure? Backpressure can help by limiting the queue size, thereby maintaining a high throughput rate and good response times for jobs already in the queue. Once the queue fills up, client gets a server busy HTTP 503 status code to try again later. Clients can retry the request at later time, perhaps with exponential backoff. Let me just make sure what is backpressuring. If you go to Google and try to find the definition, it's better here. So backpressure in code refers to a mechanism that manages the flow of data between components, especially in system with a fast producer and slow consumer. Okay, So producer means it can be the user, right? User can be a producer. User is the producer actually, and consumer is who is our server. Consumer is our server here. It prevents the consumer from being overwhelmed by data from the producer by signaling the producer to slow down. So that what I said, right? It will send the HTTP 5003 status code if already the queue is filled up. So when the consumer can't keep up, this ensures system stability, prevents resource exhaustion, and avoids data loss. That generates data, that processes data. Backpressure signal from the consumer to the producer indicating that it needs to slow down and pause the data by रुक जा. It is saying by रुक जा. बहुत हो गया. I am already filled up. I have a lot of tasks. First let me finish that. After that I will take your task. So that's what backpressure is doing. Prevents data loss. If the consumer is too slow, it might drop data if it can't keep up with the producer. Backpressure ensures that a producer only sends data that consumer can handle, avoids system crashes. Also, there are some flow control sensing not ready or buffer full, something like that. The consumer can buffer incoming data, but backpressure helps prevent. Okay, so that is what or we can also apply rate limiting. We can apply rate limiting to the API. So at a particular interval of time, let's say 5 minutes, only these many requests should be in or allowed. Let's say in 5 seconds, only 2 requests should be allowed, or 5 requests at max from per user. So we can have some rate limiting on the API. There is also an option to control the inflow in message queues, or handling the backpressure. And what piping in Node.js? The pipe method in Node.js streams automatically handles backpressure between readable and writable streams. So in Node.js, as I told you earlier, right? You can, when you implement this in Node.js, the pipe method, it is automatically handled. So streams automatically handles backpressure actually. So that is one thing. That is a good thing in Node.js, right? So that is what backpressure is. When user have multiple requests to the server. So if the queue is full, let's say this is our message queue, it will go our web server, which is this one. It will try to pick it will try to pick message queues one by one, but what our backpressure will do, it will make sure that it sends the response, that 501 response that we are already filled. Wait for some time, and after that you can try again. Okay, so that's how it works. Also you can use some rate limiting, so there should be some rate limits there should be rate limiting APIs, so we can do that. So yeah, that is about backpressure. Now comes what task queues, right? What are task queues? Let's learn about task queues. My handwriting is, let me write it nicely actually. Let me just try to write QUEUES. So what are task queues? Okay, so task queues receive task and their related data, runs them, then delivers the result. So what are task queues? It receives task is received for the task queue and the data with it. Okay, let's suppose it's a request object or whatever, or headers or whatever, the data that comes, and runs them on the server. It runs them on server, does some computation on server, computation happens, and then results are returned to the user. Okay, they can support scheduling and can be used to run computationally intensive jobs in the background. Okay, so task queues are also can be used to run background jobs and can be used to run computational things. So Celery is one of the example which is used in Python, so we can use that. And in Node.js you can use cron jobs for scheduling the background task. So that's all about task queues. Now let's learn about message queues. What are message queues? Message queues is a very interesting and it's a widely used thing. What is a message queue? Also known as MQ. So what is message queues? Okay, what are message queues? So message queues receive, hold and deliver messages. If an operation is too slow to perform inline, you can use a message queue with the following workflow. Okay, so what are message queue? There is a queue. Let's suppose there is this bucket. We put in our request. It creates queue out of our request, and our web server then pulls one ball at a time. First does some computation, then returns the result to the user, and one by one it happens, right? That's how message queue works. Now an application publishes a job to the queue, then notifies the user of job status, right? So what happens? This is our app, right? Let's suppose this is our app. It publishes a job to the queue. This is our queue. So queue can be so message queue examples are like, we can use RabbitMQ, right? Let's suppose we are using RabbitMQ here. RabbitMQ. So our app publishes the job to the queue. These are the jobs that has been published. What our web server will do, then notifies user about the job status. If it's published, then it will notify it's a success. It will be calculated on the background, but it will be success for now. So the examples are like payment. If we have created a payment of, let's suppose, 100 rupees to some user, so there is some load time, right? But it keeps on loading. There we don't return success response, it's a load response that it's loading, and after the transaction is done, we create a success response. Or in the case of NEFT, if we have NEFT transfer, what happens? We get the success response, but that amount is transferred after 1 day, or sometimes it takes around 1 or 2 hours. In BOB, if you transfer this amount, it takes around 1 day, but we get the success response that it has been transferred, okay? But the amount is updated after 1 day in the app. So that is one example of queue. And a worker picks up, let's suppose there are worker on the server. On server we have some worker. This is also part of server only, but yeah, worker and this we can separate. This is our job. This is our queue actually. This is our queue. So our queue, and these are our workers. So what worker does? Worker tries to pick one by one and try to finish that job. First it will pick this first ball and it will finish it. It will pick the second ball, it will finish it. Okay, and then signals the job is complete. Okay. In what is the benefit of using message queue? The benefit is that user is not blocked, right? User is not blocked and job is processed in the background. So both are happy. Server is also happy, server is not overloaded, and user is also happy because user has passed its request, and now it will keep on working in the background. During this time, the client might optionally do a small amount of processing to make it seem like the task is completed, right? For example, like if you are posting a tweet, the tweet can be instantly posted to your timeline, but it could take some time before the tweet is actually delivered to all your followers, right? So what happens? We can do a small amount of processing. After we have published the job, what we can do? We can make sure that the content the tweet which has happened, we can show that in its own user feed. So what we can do, side by side we can update the user that has responded its own data or its own feed, and after that what we will create jobs for updating his content to its followers. So that will take some time, right, to show on its followers list, depending on the bandwidth or on the server RAM or computational power, right? Now what are popular message queues? So Redis is also one of the message broker. Okay, not this. Redis, RabbitMQ, AWS SQS, and what Apache Kafka is also one example widely used. I think Node scheduler, I'm not sure. Yeah, that's also. So these were the examples of message queues. So yeah guys, that's it.